Hi everyone, my name is Antokhina Julia, and today I will talk about some useful stuff which I learned from practice being a data scientist. I mean software engineering life hacks for data science. My background is Moscow State University Computer Science Department, and currently I'm working at Mobile Telecommunication Systems in Big Data Department. I was working on classical machine learning tasks, and now I'm working on recommender system. Feel free to contact me after lecture if you have any questions. You may write via email, or for Open Data Science, it's a Russian community for data scientists. So, talking about motivation. When I started learn machine learning, I struggled with some problems. For example, mixed naming, spaghetti code, problems with saving your models, and all this stuff seemed very tough for me because I didn't have any engineering background. And I think a lot of you also managed somehow with these problems. But after a few attempts, I found out that there are very easy ways to deal with these problems, and I want to share with you these methods. First, we need to talk about differences between work and study. For example, when you are studying, you have the whole term for one task. You have many attempts. You may do a lot of mistakes and want to learn through making these mistakes. But on real work, you do not have all these possibilities. And last but not least, you need to make reusable results that your colleagues can use too. What are easy ways to deal with it? To limit errors, the easiest way is to show your work to somebody else. But it's very time-consuming. And for reusable results, you need to provide code which is easy to read. But when you don't have any software engineering background, it's very hard to find out how you should write your code. So, from practice, we learned that this stuff, code review, structuring your repository, clean code, and refactoring, and also some small features for Python notebooks, helps a lot. And I'll tell you about all this stuff. First thing I'll tell you about is code review. Code review is process when you're showing your code to somebody else and your colleagues watched your code and commented. And then you see that comments, you can fix some mistakes or make your code better. Who doing code review? If the project is very useful, there should be two specialists, a data scientist and a software engineer. But for smaller tasks, it's okay to be only your data science peer. First code review may be very tough. Your peer will find a lot of mistakes, but that's okay. You'll learn a lot and very, very fast. Code review is a process of learning and making your results better. This sounds good in theory, but how you can provide code review in real life? We found out one way, but first we need to talk about your repository structure. Repository is the place where you store all your code, and there should be some conventions, for example, fixed naming, focusing on some structure with folders. For example, you always name your folder with notebooks as notebooks, not the notebooks, others, code, or something else. and this should be shared in your department. Then you need to store all your models in one place. For example, if it's a small project, it's enough to store all your code in SRC folder. But if it's a bunch of projects, you need to have a common folder in which you will store your shared code. It's obligatory to have requirements.txt. Requirements are fixed versions of the libraries which you are using when you are making your project. You can easily find out which versions of libraries do you have, type in pip-freeze. It will show you all the libraries which are installed in your environment, and you can reproduce your results with virtual environment. For example, on the slide, you can see the picture. Their virtual environment is named MLRepa Pi36, and that's the name of it. Virtual environment is very useful stuff because it helps you to sustain reproducibility of your code. There are a lot of strange examples in which libraries are changing. Some libraries are changing faster than others. For example, CatBoost is changing faster than XGBoost. It depends on the library, but you always need to fix these libraries, because half a year, if you need to reproduce these results, it can be impossible. We always fixing libraries versions. And you should fix the version of your Python too, because different versions of Python behave different ways with different libraries. For example, some libraries doesn't work with Python 2.6, 2.7, and only works with Python 3.5 or 6, but not working with maybe 7. I don't know. How to make your virtual environments convenient in Jupyter notebooks? You can install your virtual environment into notebook interface by using ipykernel. You need to activate your virtual environment using source activate, then install ipykernel, and then type the command you can see on the picture, and it appeared in your notebooks. And it's very convenient way to use virtual environments. The other very useful stuff is using never syspath append, but providing path file to your virtual environment to provide the way you access your written models from the Jupyter environment. The common way to deal with it is using syspath append, but it may cause a lot of problems. For example, we faced a problem when we were saving our model into Pickle. Using syspath append caused problems from repickling that model. So when we tried to reload that model, it caused a lot of errors, and it seemed impossible to us. Other useful stuff for repository is using standard folders for DVC and for tests. And tests help you to write your code even better, but I'll talk about it in my next speech. And you start with prototyping your model in notebooks. For example, you may find useful to make numbers in the naming of your notebooks or any other convention which you find convenient. And then you rewrite that code from notebooks into models. Other very useful stuff to work is working in branches. Branches is your virtual copies of Git repository in which you can work in parallel, and then you can use these branches to make code review. How to make branch in Git? Easy way is to do it via API. You just type new branch, then you make a branch. You are writing the source branch. For example, your source branch may be master or dev. When you pull this branch from remote repository, you check your branch to this branch via git checkout. You add your code, you commit it, and then you push it again into repository, and voila, it appears in that branch. This mechanism helps you to work with your colleagues in parallel and not making the mistakes of fixing the same file or the same folder or the same code. And it also helps you in code review. It is very convenient to make code review via merging branches from your local branches into the main one. For example, main, master, dev. First, your code should be in modules because it looks better in Git API, and you should develop it in small chunks, thus it's easier to check. When you're pushed all your results into branch and you want to show it to your colleagues, you need to create merge request. You type create merge request when you're writing into what branch you are planning to merge results. You're writing your assignee, who will check your code, and you type squash commits. It helps you to make from many commits only one, which will appear in the main branch. If you are not finished your work yet, but you want to show it, you type work in progress, which makes submitting with this branch impossible, but you can comment it. Merge request looks nice because you can comment your code in modules or your TXT files or your requirements files. And if you want to push some Jupyter notebooks into your repository, you need to copy paste your code and write it in Markdown. This is not the best way, but quite easy, and we use it. And when you are submitting merge request, you can comment it many times, like you see in the picture. Then you fix some mistakes, you are making new commits, and after that you may store all your progress of what you were doing, what were the mistakes like, and then after all that done, you merge it. And that's our code review. What are pros and cons of code review? Pros are you have less errors, you are sharing your knowledge with colleagues, and you are also learning a lot how to code well. If it's a lot of colleagues who are watching your code, you all study very fast and you all learn really well. But the minus is that it is so time consuming and you don't want to waste your time a lot. So, how to make it more efficient? Or what is the best way to organize your code into modules? These are new questions. And the answer is clean code. You may hear about PEP8 convention, which was written by Guido van Rossum, the author of the Python language. It tells you about how you should write intents, white spaces, how you organize your code, how you comment your code, and have some naming conventions. It's very easy one, and I recommend you to look at it if you don't know Pipade. There are many style guides. Style guides is document in which is written how you organize your code in general. For example, you may use Google Python code style. It's very nice and bigger than Pipade. There are some rules in it which can be discussable, for example, the length of the string, but you may not go for it if you don't want to. But which I learned from practice, all the rules are very useful. For example, if the naming convention is writing the variable name from the low space, you may find out then you mix the low space and not. You have several variables which naming is the same except the first letter, which is not very nice. But the main thing I want to tell you about is Clean Code. Clean Code is the book which was written by Robert Martin several decades ago and still very popular and useful for young software engineers. These are rules of not just organizing your code, but writing it well. Like it's in the picture, you just need to fix a lot of mess in your code and making as clean as possible. And it should be as a non-fiction book, easy to read, very clean, very distinct. First, you need to make your code work, and on that stage, it may be dirty, not convenient, not easy to read, but that's okay. Everybody does it. But you need not to stop on that stage, but keep trying to make your code better. For example, after that, you make it right, and you're trying to make it short. You're trying through some rules, which helps you. Maybe you are going through code review, and after that, your code became better. Simple rules from first chapters of the book are naming. Your variables should be short and meaningful. For meaningful, I mean that they should not be X or Y or I, and they should not be very long, like this variable for counting our users. This is very long and hard to type. But they should be pronounceable. For example, the variable with name like pbdijk is hard to pronounce, even if it has some meaning behind it. Thus, you should avoid of encodings like C360, which is a short way of naming customer 360. That's maybe a table which contains information about your customers. And the variable should contain meaningful context. For example, daily or monthly, and that should not be provided as a context like variable X. This is not meaningful name, but pronounceable. And as for easy to search, if the variable too short, for example, var, you may find it in many variables, and it would be very hard to search through that variables in your code. Second useful stuff is the functions. Your functions should be short and easy to understand. On the slide, you can see the function which is doing the whole pipeline of loading your data, pre-processing your data, and training your model. Maybe it's even giving you some scores, but I'm not sure. And it has commented code, which is not nice either. And it's hard to understand from the naming of the function what this function is doing. So the functions should be small, and it also helps you to test your functions, because it's almost impossible to test your code if the function is very long. The best way is to make functions short, clean, with few arguments. And in ideal world, it should have a structure like input, variable names, transforming this input, short one, meaningful part, and then output. And the output should be the same in function. For example, if it works well, it's some scores, and if it's not, the result is none. Not nice. The next big thing is comments. Commented code, you may find it very unuseful, especially if it tells you the wrong information. For example, you are counting some metrics, and in the code there is comment. This metric should be blah blah blah, and the metric is different. Is it not fixed randomness, or is your code broken? You're not sure. So the comments should be only in situations in which they describe why you done this thing. For example, you tried one library, and if it doesn't work, you tried other library and it doesn't work. And when you find a way to write that code well, and you may write a comment why you've chosen this non-obvious library. That would be the nice comment. And talking about formatting. This is the easiest win from that speech. When we started formatting well in our company of data scientists, we find out that we read code twice faster and write it twice faster as well. To learn how to format your code well, and the main rules are type 8, but it's not very convenient to check the whole list of type 8 every time you format your code. So you may use a library. I recommend you to use Black library because it formats your code the same format every time. You may install it via pip, and it's also a site in which you can test this library called black.now.sh. And this library is so-called auto-formatter. So it automatically formats your code. Auto-formatting helps you to standardize your code, to make nicer code reviews, and also helps you to avoid some Python bad mistakes. These are the most popular auto-formatters in Python. Black formats your code same format every time. The developer of the Python, he checked different options and chosen most universal ones. Other one is PyLint library. It has a lot of settings, and you can store these settings in the file and share it through your codecs. And the last is Flake8. It contains several libraries like PyCodeStyle, which checks your style errors, PyFlakes, which checking Python errors, and Macape for complexity checks. For complexity checks, you may check wherever your code is nice or not so. Refactoring is the things which contains all three above: code review, clean code, and your repository, because it's the whole process of changing your code without changing its functionality. But you should avoid mistakes while changing your code, and you can use tests for it. You need to remember that changing your code is progress and not perfection. The whole time you have for technical debts, you may use for refactoring, and each time you are doing that process, your code may appear better. There are several concepts before refactoring. First is code smells. Code smells are some marks that your code is not good enough. For example, very large classes, very long methods, some long parameters list, like it was on the slide with functions. And there are several standard ways which can help you with refactoring. They called design patterns. You can learn design patterns from practice, but it will take a lot of time. So you may just read about the ones which you can find very often in your code. There is a nice site, refactoring.guru, which you can read for most common design patterns. I recommend you to. So the whole workflow to making your code better is first to make prototype in Jupyter notebooks. Then you submit your code into models and fix virtual environments. And when you are doing your code review, first you're making data science code review, and next you are checking your code, and you also need to check reproducibility of your code. This seems pretty obvious, but on practice, if you're starting to use these simple methods, it helps you a lot in your work, and you may provide models twice faster than you did before, and with high quality. And the last thing I want to talk about is some cool features for Jupyter notebooks. These are clean code for Jupyter notebooks. Your notebooks may be useful too. They may contain some EDA, some tables chunks, or some preprocessing, which is more convenient to do in Jupyter notebooks than in models. But in the best way to make your work more convenient, you need to make your notebooks clean. The main idea, one notebook, one hypothesis. And that should be structured too. For example, you are checking the hypothesis that this variable have some distribution. You may show it in one notebook. Notebook should be short, easy to read, clean, and have structure not only in the notebook but in cells too. The cells should be structured like their functions. They have their idea, execution, and output. And output should not be mixed with some preprocessing or any other code. For example, if you are typing dataframe.head and you're watching some results, you don't want to mix this cell with some preprocessing stuff. Code smells for Jupyter notebooks are duplicated cells, mixed cells order, which is very, very often, and makes your notebook non-reproducible at all, and copy-paste cells. Then you're finding out that you have copy-paste cells. Maybe you want to put this code into models and use it as a function, especially clean function. This is all for writing clean code for Jupyter notebooks. Maybe you know about EDA for programming, but in Jupyter there is an extension which makes your code writing a little bit easier, and that's called NB extensions. Most popular extensions are execution time, which appears in every cell you execute, scratchpad, autopipette. You just press one button and the whole cell is formatted for pipette format, like the black does. CodePrettify stands for making your code for Google Python code style. As you can see on the picture, you may press one button and it makes your cell look well. Table of contents is nice for big notebooks, but they're not very easy to use. maybe you should avoid it. 2 to 3 converter stands for converting your code from Python 2.7 to Python versions 3. On the slide, you can find the instruction how to install it. And the last useful thing for Jupyter notebooks, which I want to share with you, is paper mill. Paper mill helps you to make your notebooks as a functions. Example, you mark one cell of your notebook as parameter cell. You make it in Markdown maybe. And then in the other notebook, you can change that parameters and rerun the whole notebook again. And this library will provide you the output of that notebook. It's a convenient way to see some EDAs, some distributions of your tables, for example, for different bunches of data. The pluses of paper mill are that you have separated output. It works well for parameters, but it has limited abilities. And the paper mill is also suitable for integration testing. As for testing, if all the stuff I talked about is not enough for you, and you want to make your code even better and be sure that you limited mistakes as much as possible, you should use testing. Testing is very easy, and I'll talk about it in my next speech on this festival, testing for data science. So, and that's all for now. The recap. Readable code means reproducible code. Reproducible code cannot be non-readable. And perfection is a progress. You are not making your code perfect from scratch, but you keep trying to make it better, and after that you can have your successful code. So, thank you for today, and see ya!